Tuttle here. It's storm season in Oklahoma, and with that comes torrential rain, high winds, and hail. To protect your home and your family from these threats, the one roofing company you should trust is Ferguson Roof Systems. They've been providing the best in roofing services for nearly half a century. Ferguson is Oklahoma's full-service roofing company, certified with an A+ Better Business Bureau rating and a 5-star rating on Google. And with Ferguson now offering Class 4 impact-resistant shingles, now is the time to trust them with your home's roof. Get started today at FergusonRoofSystems.com.
Hey everyone, Meteorologist here in Tuttle, back with you again. It is, what time? Saturday night? What night am I on? Saturday night, 9:30, that's what it is. Thanks for joining me. We're going to talk about the severe weather threat for Sunday, see what's shaking and baking, if we're going to deal with hail, wind, tornado, all that kind of stuff. So glad you could join me here. Hope you've got a nice, calm, relaxing evening planned. Thanks for stopping in. Make sure you enjoy your sleep tonight. Remember, sleep is important. Get as much as you can. There's never enough of it, I know. Same here. So, hey, Jacqueline, good to see you. Leslie's in the house this Saturday. Melanie, Crystal, Karen. Of course, Mrs. Tuttle is checking in. Got to give her a shout out, or I'll hear from it later. I say, you didn't say hi to me. I'm like, okay. Karen, let's see. Larry's in the house. What's up, Cindy, Patty, Michelle? Thank you, David, for some stars here on Facebook. Already sending me some love. Nanette as well. Leslie, thank you for the stars. Danita, Rami, thank you. Hey, Mary, good to see you. And Cammie. Yeah, it's going to be a little windy, so I'm glad you asked that question. We will talk about the winds. You guys on YouTube, I see you. Homesteading with a Purpose. Good evening. Lisa, good to see you from Mustang. Let's see, who else we got? Jerry's in the house. Larry, Eric, Gopher's World from near Orlando. Whoa, get back. Kathy's in the house. BJN, Hillary, and my boy Jeff is in there. Same with Robert. And Flocked Up. I gotta be careful how I say that really quickly and clearly. All right, you guys' names are killing me. Okay, so let's take a look at what is happening out there currently. So, you know, we did see little clouds out there, and we also saw some sun. But it was actually a pretty decent day, believe it or not. We got about right at 60 degrees, so it wasn't too terrible. We're not really falling that much. Now, it did start off kind of cold, though, unfortunately. But anyway, so it's a nice evening, and we've had a southeast wind, mostly on the light side today, and that'll be changing as we head on into tomorrow. It's going to be quite breezy. By the way, in the Facebook group, I did post the link where you can opt in for weather updates. There's 3 options there, 3 links I post. You can pick one, and that way you can always get the updates when I do go live, so you don't miss anything. In case you're watching the replay on this and you're missing out and you're going, what happened? How come I didn't get notified? Blah, blah, blah. Well, now you know. Like I said, temperatures this morning were pretty cold. The minimum air temperature, we actually had a freeze out here in the northwestern third of Oklahoma. It did get down to the mid-30s here in Oklahoma City, 33 out in Yukon, 32 in El Reno, otherwise near 40 out in southeast Oklahoma. So hopefully your plants are okay. Got a couple more cold mornings, I think Monday and Tuesday, I think we've been talking about here for a while. So again, if you're going to be one of those early planters, you just have to be careful. Out there currently, we've got temperatures into the 50s across the state. No showers, no storms out there yet. We'll get some rain developing, though, late tonight into tomorrow. You see this little faded area here where it's green and brown? You know what this is? You don't want to know what this is, but you know what this is? This is a 5% ring for tornadoes from the Storm Prediction Center. The green, which outlines from there, which goes all the way around this little area here. Matter of fact, I'll turn this off so you can see it better. That way it's not in your face. There you go. So now you can see the differentiation of where there is a 2% probability of tornadoes. Now, if you're going 2% sounds pretty low. You're right. It's basement level low. So that's good news. You don't want to be in a higher probability, right? All right, well, let's take a look, see what that looks like elsewhere across the country. I want to show you, there's a big weather system coming in across the northern plains. So you see all this mess up here. This is all winter storm watch and winter weather advisories. You can get a lot of snow, 2 feet in some cases or more. Some ice underneath that as well in some areas. Out in the Northeast today, they also saw quite a bit of snow and some ice, and so they've had a lot of power outages out there. And then here into, of course, the central part and southern part of the country, we have all this brown area. Well, brown means wind for us, so these are all wind advisories, and the red is kind of a, I think it's a red flag warning, basically kind of a fire danger kind of a deal. So, but we are going to see these winds pick up, and so that's what the brown is for. So high wind watch, even is what they call it. which is, more wind than even a wind advisory. So there's a wind advisory here across the little light brown area from central to east central Oklahoma. The brown is for western half of Oklahoma for a high wind watch, and that's just going to mean winds getting very excessive, right? So we're talking, excessive, probably 40 miles per hour. And out here, of course, the west, you have kind of a combination, red flag warning, high wind warning, all that kind of stuff. All right, so in other words, that is just windy is what that really means. Okay, when we look at the hazards for tomorrow, up here in the north, all this area here where you see yellow and red, those are actually moderate to major impacts for winter weather. All right, so Minnesota, down here across eastern Nebraska, and then this little ice area right here south of there. So again, travel up here discouraged on Sunday and Monday. Blizzard-like conditions, it'll be a mess. All right, well down south of that, we're of course we're going to be a little bit warmer and some moisture to work with. So this is the slight risk of severe weather. So in the yellow color here, and that's across Wichita, here in northwest Kansas, back into northwestern Oklahoma, green elsewhere for a marginal risk of severe storms. And I kind of already showed you where the outline was for the tornado part. We can show that to you as well. Probabilistic of tornado. In case you missed it a minute ago, there, a little brown spot. Okay, so I'll turn that off and just leave the tornado part red on there. So that takes us up to Wichita, Salina, kind of west central Kansas, Hutchinson, and then back here into northwest Oklahoma. All right, but that can change, just so you know, that's just from the Storm Prediction Center. When we look at AI generation, of where it thinks the better probability of tornadoes are going to occur, it backs that up to the west a little bit and down south. So that little brown area you see extends all the way down now northwest Texas, also eastern Colorado, and southwestern Kansas. So we'll see if the humans go toward the computers. The robots. Who's going to win, the robots or the humans? All right, let's take a look at the significant tornado parameter from the NAM high resolution data. All right, so when you see the colors showing up on the map, that is where you have favorable conditions for tornado genesis. Now, the issue is the scale goes from light to moderate. So tomorrow, you're going to see these little colors here in the yellow and orange. Let's go right around here. See that right there on the color bar at the bottom? So once you get to about 3, so that's still kind of in the low middle part of the scale. It goes all the way up to like an 8.5 or 9. All right, so that does, in other words, it's got some ingredients, but it's not, really great. In other words, there's something there, so we'll probably have a little bit of a threat, but it's not like it's Katie bar the doors threat. All right, so let's take a look here. That's the evening hours. So kind of focused out here in the western third of Oklahoma. As we go into 7 and 8, 9 o'clock, now the wind shear will kick in as the low-level jet kicks in right around dark, and thereafter for a couple of hours. So that's usually what spikes up the significant tornado parameter. As we go into the evening hours through 9 and 10 o'clock, you see it kind of shifts now more into central Oklahoma, kind of along the I-35 corridor, and points west here around midnight. And then after 2, 3 o'clock in the morning, it kind of starts to vaporize a little bit. So what we have is kind of a little bit of a lag, and I'll tell you why this is occurring, and then we'll zip here into the reason for that. So let's take a look at the dew point values. Okay, so dew point's a measure of moisture in the atmosphere. We have a southeast wind with the dew point value into the low 40s right now. All right, so obviously it's pretty comfortable out there. All the juicy stuff is down on the coast of Texas, but we will get some decent dew points coming in here with the darker green colors. Here's 9, 10, 11 o'clock, 1 o'clock. We're all going to have some mixing that does occur during the day, which will drop those dew point values a little bit out here. You can see some pretty good dew points here, though, in the darker color of green. So at 5 o'clock, for example, our dew point here in Oklahoma City is right around 52, 53. And then we do have a developing dry line out here right across the Texas state line. And then that dry line kind of gets a push a little bit just to the state boundary. And that should fire thunderstorms off in this area here. And that's probably going to occur between 3 and 4 o'clock. All right. So the point being is this moisture that's coming in is late to the party. All right. If it was earlier to the party, then these storms out here would be trouble. But they're going to be high-based, hail makers, pockets of wind, but they will probably not be able to produce a tornado because they don't have the low-level juice when they first start out. Now, as we go to 6 o'clock, remember they start 3 to 4, that's a couple of hours. Now, if we go to 6 o'clock and 7 o'clock, what we do have eventually is this moisture starting to deepen a little bit into this zone. And I talked about this on my Lunchtime Live on Friday. It'll be a last-minute push of moisture, deeper moisture to get here as the storm starts to approach after 7 o'clock. So there's 7 o'clock and there's 8 o'clock. All right, and there's 9 o'clock. So now we have dew point values close to 60 coming in. And you think, oh, what's the big difference between 50 and 60? Well, how about a tornado or two? That's a pretty big difference, wouldn't you agree? So yeah, so when you get these higher dew point values, you get more moisture in the atmosphere to work with. All right, so here's 10 o'clock and 11 o'clock, and there's 1 o'clock and 2 o'clock. So basically the bottom line is you can see how the theta E axis runs right up I-35, meaning warm and unstable atmosphere with higher moisture rates. And that is what's going to fuel any thunderstorms that are still out here or that are capable of growing with a south wind. We also have winds that are aloft in the atmosphere, quite strong above the surface, and also at the mid-levels at 500 millibars. So we have a lot of wind shear to deal with in the evening hours after dark. The question is a cap built in, which usually prevents thunderstorms from forming. And I'll show what that looks like here in a minute. All right, so let's take a look here at the model forecast for cape and shear. So by 7 o'clock, here's where the cape and the shear overlaid is. So it's kind of in this little quadrant here of Oklahoma. So it's very faint. It's not an overly excitable air mass. In other words, this is like a barely marginal ingredients to produce what we're going to have. If we were to have, say, a whole extra day to get stuff in here when it comes to moisture and heat, it'd be a totally different outcome. It'd been a lot more, banging of the chest and screaming out the windows. But for right now, it's kind of in a marginal situation of ingredients, but they are enough there to cause some severe storms. So we do take a point forecast sounding in that environment. So the model says basically a marginal tornado. It has a pretty high level base out here west central Oklahoma prior to 7, but from 7 onward it starts to lower. And I picked 7 o'clock, so we're kind of in the sweet spot here. And there's no cap yet building to shut things off, but it's getting close. But we can see temperatures and dew points kind of on the cool side in the mid 50s. So if we go into the 8, 9, 10 o'clock, let's just go to 10 for example. So we can kind of see how the difference is in the atmosphere, how it's changing. So we'll kind of stick out here into this spot I was earlier just to show you what's going on. So the model likes instead of marginal tornado risk, has a flat out tornado risk. It has a lower level condensation level because there's a lot more deeper moisture right here in the forecast sounding profile. And there's a little cap right here. It tries to get going, but it doesn't really quite do it. So in other words, it still has a very, very weak cap overhead, which is almost non-existent. So that means any storms in this environment can go up should be potentially tornadic. All right, and again, that is in this little sweet spot I was outlining here, and that was around 10 o'clock. But again, we're assuming the model is perfect at picking out that axis. Let's just say it's a little bit more east. All right, let's say it's over here in El Reno, for example. Anything change? No. Tornado type, hazard, pretty decent photograph. Lifting condensation level very low, very good turning with height with a shear, and a very deep moisture column. 59 degree temperature over 57 degree dew point. So that is cool. It is on the cool side. Normally you think tornadoes, you think warm and humid and muggy, right? This time of the year you can get away with less cooler, warm air at the surface because these temperatures up here aloft are much colder. They haven't warmed up yet from later in the season. So yes, this can be a favorable position for tornadoes here across central Oklahoma during tomorrow evening as any of those storms do work their way through. Here's 1 o'clock and 2 o'clock in the morning. Still got that higher cape values around 1,000 joules or so along the I-35 corridor, but the shear is becoming less and less favorable with time. So there's going to be a sweet spot there probably of mid to late evening, and then it'll drop off. The cap will probably build in, and then the shear is not as favorable. So we could still have at least a potential of a couple of tornadoes across central Oklahoma through about 1, maybe 2 o'clock in the morning. When we look at some of the high-resolution data, and I'm going to have to use a couple of different ones because all the data hasn't quite come in yet. This is looking at tomorrow morning. You will be seeing some showers to start the day scattered here across west central and central Oklahoma as you get up in the morning and then through about lunchtime. And then that activity will start to move off to the east. I'm going to switch model deals here. All right, so there's that morning shower activity for noontime moving on off in eastern Oklahoma. So some scattered showers for you guys, nothing severe for eastern Oklahoma, Tulsa, Muskogee, etc. However, look out here to the west. So let me stop it. There's 4 o'clock. So there's 4 o'clock. So there's this model already has the thunderstorms developing that we talked about for 5, 6, and 7. So you see how they kind of move through this favorite area we talked about with that instability and shear. You see how they're kind of broken up into individual clusters of cells. So again, potential for a lot of supercell activity where they're separate from one another. That allows them to rotate, not be interfered with too much. So you get some pretty decent hail and some pockets of damaging wind, and yes, that threat for a tornado or two. And there's 8 o'clock, but you will notice they start to diminish. There's 8 and 9. All right, so typically what happens is the cap starts to build and it starts to shut things down. But the models are run at that questionable period as to whether or not that'll happen, because there is some other additional lift that comes in. So for example, 11 o'clock, 12 o'clock, there's still some hints, there's still some thunderstorms out there. So even though by far and large they should probably calm down, there may still be in 1 or 2 rocking and rolling during that time frame. Like I say, here's 2 a.m. So there's a storm that develops out of nowhere with a cluster here on the east side now of Oklahoma City, between there and Tulsa, down into McAllister. So that's what I'm saying. So the models are saying, yeah, the cap source kind of starts to build in a little bit, but because it's the time of the year that we're in and the moisture we're getting surging in overnight and the shear that we have in place, might get a couple overnight thunderstorms that might produce a tornado. So that's kind of what that model data is hinting at. When you look at the Texas Tech model here, I like this sometimes. Its big story was, again, the morning showers across central Oklahoma and eastern Oklahoma in the afternoon. And it does have some helicity tracks in this favored area here in northwest Oklahoma. It doesn't have helicity tracks down here. Doesn't mean that won't occur. It's just that is where it's favored up to northern parts of the state, where it seems to think there's going to be better ingredients here in central Kansas and far northern Oklahoma here during the evening hours for Sunday evening. Now, helicity tracks basically tracks the mesocyclone, which produces the large hail damaging wind and potential tornado. So those tracks are obviously something to keep your eye on, because that's where you have your trouble. But again, I think that could happen to any of those storms south of there as well. Okay, so that's about it with that one. Let's go into the details of the forecast. You guys asked about wind a minute ago. So those winds will kick in out of the south overnight into tomorrow. You'll start to hear them cranking. So if you're a light sleeper, they'll probably wake you up blowing stuff around. By 6 o'clock in the morning, wind gusts are going to be well over 40 miles per hour. There's some around 50 here, especially northwest Oklahoma. Good grief, that's a wind gust up around 56, 57. Just so you know, and of course some of that won't make it to the ground during the morning inversion, but the point being is a severe thunderstorm warning type criteria for wind is 58 miles per hour. So that kind of gives you an idea. It's going to be pretty windy. All right, so there's 10 o'clock, 11 o'clock. There's more of that yellow showing up midday, which would indicate some of this would make its way to the surface. What was that anyway? Up is up around 60 miles per hour. Oof, it does happen in Oklahoma. We do get severe damaging wind even without a thunderstorm. So that's kind of what this is indicating for tomorrow, due to a very strong return of a low-level jet. All right, we go to Sunday afternoon. Those winds still hanging in there. Again, out of the south, up around 40-plus miles per hour. And then we have those thunderstorms. They'll start to develop in the evening hours. So see, we'll keep the winds going even outside of the storm, still in that 40-plus category. So, man, that's going to be really the big story tomorrow. So if you don't see any storms in your area, you're still going to get a ton of wind all day long, even into the evening. So anything you have that's loose and needs to be battened down, put the hatches on it. And see, let's go to Monday morning. Then those winds start to calm down. Then things kind of quiet out for the rest of Monday. So it's looking good there. All right, let's take a look at the precipitation amounts. Now, what the model will try to do is predict where these heavier thunderstorms trains will be. So here you have, these little pockets here that trail like this. That won't be exact, but what it does is tells you that when you do have this type of situation, you're going to pick up an easy half-inch, 3/4 of an inch of rain if you have some of these thunderstorms. The rest of the area may be hit or miss. You might not get a few sprinkles, may get nothing, or you may get 1/10 or 2/10 of an inch, depending on how much rain comes over your area. And this stuff is going to be the second round as you head into Sunday night and then Monday, really on Monday. So repeat there. Okay, so let's go into the temperatures. So we're looking at 60, so still on the mild side here for Sunday and Monday, and then a little cooler for Tuesday and Wednesday. If you do notice these temperatures for Tuesday and Wednesday, this is the Oklahoma City forecast, but your town will be similar. You can use my weather app, AT's Weather to Go. It'll track those tornadoes, by the way, if they do occur, and give you lead time to seek shelter up to 20 minutes. But they'll also tell you what your local forecast is for temperatures. And so, again, if you're anywhere pretty much anywhere across the state on Tuesday morning, and at least the northern half of the state on Wednesday morning, you're looking at a freeze, frost, some other areas. And we do start to warm things up for you. So we're back into the 70s and 80s for next weekend. So looks like we're finally going to get a decent weekend where the temperatures are going to cooperate, and we're not going to have to deal, hopefully, with a bunch of thunderstorms. We'll see. Usually, what you see here, when the temperature goes downward from one day to the next, You know, usually that means there's been a cold front in here, and I looked at some data before, and there was another system that comes in here for the 31st of the 1st. We'll likely probably get some thunderstorms that Sunday night, so another repeat 7 days away. You know, it's funny because, believe it or not, the weather does run in 7-day cycles a lot of times. That's just how the Rossby waves move across the globe. So when you get these big, broad troughs, it's like a cyclical dance. And you can get stuck in a 7-day pattern, and this just is what it is. So it's not out of the usual. It's just what days that pattern set up on is the same day. That's why it can sometimes seem like it's always a weekend and gets messed up. Well, every 7th day, you know. Anyway, back to the comments. Just want to say thanks again for checking in tonight. Diana, thank you for the stars, and Amanda. So yeah, you can get any activities you want to get done for tomorrow. You're all fine. Remember, the morning is wet up through lunchtime, so keep that in mind. But then after that, you've got several dry hours if you're in central and western Oklahoma until late afternoon, and then get your stuff done for the evening. So Nancy, it's just fine, just wet flats in the morning. Let's see. Tanya, thank you for the stars. So Kevin says, I've seen thoughts from the National Weather Service discuss a line forming. Would those be QLCS type tornadoes? Just tuning in. Okay, so yeah, in that particular case, when you have a supercell type structure, it's going to be that standard supercell producing tornado. And then when you have a linear convective squall line, you end up with what we call QLCS tornadoes. And if you're new here, you're going, what's the difference? Isn't it tornado, tomato? Is it one of those deals? Somewhat. So with the supercell, if you have better ingredients to work with, you can get a tornado that's registered with a wind speed in the EF, what we call 5 category, which is the maximum they go to. They go from 0 to 5. Where you've got wind speeds that can approach 300 miles per hour, for example. So that's the worst of the worst. Those are extremely rare. They happen a couple of 2% or 3% of all tornadoes ever. So they're obviously that's pretty rare, right? Your odds are good that you'll never see one of those in your lifetime. But except of course, if you live in certain parts of the country, your odds will go up on that, right? So like you live in Montana or somewhere out in the West Coast, you're never going to see that. But if you live in Oklahoma, Kansas, there's a probability for everything. For where you live, but there's also probably just in the number themselves. So anyway, so those supercells can produce those types of tornadoes. They can, given all these other ingredients and everything lines up just right. It's perfect. On a squall line time situation, basically it's where all the lines merge together into one single line. Then they lose their supercell characteristics. Sometimes you'll have a supercell embedded within the line, and it gets really messy. Those don't happen as much. And then what you end up being otherwise is kind of maybe a leftover supercell. It's lost its characteristics. It's embedded within the line. But there's still a lot of spin left in the atmosphere, a lot of vorticity and spinning. And then you end up ingesting something along the leading edge of the line, basically like a little eddy. And it can mean anything. It's like, think of a glorified dust devil, something that's causing a little spin, either from the atmosphere on some other boundary it intersected with, or just in the way the wind field is, or some kind of convergence zone. So anyway, you can get some little spin up that's on the leading edge of that. It doesn't have to be much. And what will happen is an updraft along the leading edge of that thunderstorm line will take that little area of spin and basically magnify it. It's like giving it a boost. So, it's like going from low octane to high octane. And all of a sudden, now that little teeny tiny dust devil type, wind field that you really couldn't even see, that may have only been like 30 miles per hour, no big deal. All of a sudden is now magnified times 10, and so now it can form a little mini tornado out of it. And those, usually in those type of situations, a squall line is a EF0, EF1. Those are the most common. Now, every now and then, you can get an EF2 or an EF3 in those QLCS ones, but they're very rare, and they don't last very long. They're very short-lived, whereas a supercell type tornado can typically be much longer-lived, again, depending on conditions, whereas the QLCS doesn't have a chance for that. There's no way a QLCS tornado can last 30 minutes or an hour or 20 minutes. They're on the order of magnitude of seconds to a few minutes. I've rarely seen them exist longer than that. Just is completely different formation. So that's the good news with those. So if you do want a tornado, you want an EF0, which is basically a gentle breeze. That's the best way to put it. And so then obviously the QLCS one's the one you'd want in that particular case. So that's kind of how that is in a nutshell. So this year, you're going to hear the difference between, QLCS and supercell, and we'll try to explain that for you. But for those that are new, that's basically the bottom line. All right, let's see. Yeah, so Brandon was asking about the winds for Oklahoma City. Yeah, tomorrow the winds are getting it cranking. Remember out of the south at 40, 50 miles an hour. Some gusts higher than that. So he's asking about flights. So basically, what the airlines will do is that they land and put flights in where they're not going to get a crosswind, obviously. So they're going to try to line the airport runways, incoming, outcoming flights associated with that. So northbound, southbound flights, kind of a deal. And those planes can land in that. Will there be some delays? Probably, maybe. I don't. It's up to the how the air traffic controllers decide to work all that and the pilots and stuff. So that's on that basis. But anytime there's weather around, then obviously that's usually a problem that does affect other things. So Dylan, we'll be going live tomorrow. So I'll probably do a lunchtime live, maybe, or late afternoon live. Kind of see if anything's changed. I might just do a simple post, on Facebook and etc. social media. If it looks like tornadoes will be developing, then I would go live for that. So it'd be in the evening hours, and then I would track those. I only cover live tornadoes usually, or a very high magnitude wind event, over 70, 80 miles per hour, over a large area with a lot of huge hail maybe as well. So only high extreme magnitude events I usually cover, because the rest of the stuff is just normal thunderstorms we get here across Oklahoma all the time. As long as you don't go out there and play in it, you're usually fine. So it's a good question. By the way, you guys on YouTube, again, just thanks for checking in. Jill, I see you, and you're welcome, and thank you for the tip tonight. Appreciate you, lady. Let me see here. I was on YouTube. Jim, I see you from Mustang. You came a little late tonight, man. I was looking for you earlier. Let's see. Jennifer and McAllister checked in. Good to see you. I like it when you guys come in from all over the state. Always like seeing that. And, of course, Mrs. Tuttle's in the comments answering you guys' question as always. You're welcome, Brenda. Yeah, the El Reno stuff is a once-in-a-lifetime event, hopefully for everybody. We don't want that again. California. Dennis, welcome. We got a lot of Californians here in Oklahoma. I'm telling you. Yeah, hit that like button, Christy says on YouTube. Yeah, make sure you subscribe to the channel, hit the like button, share all that kind of stuff. Same thing with Facebook. So, yeah, Casey, if you do see a tornado tomorrow, it would be on the lower end. So, no, Joseph, it would not be strong or violent at this point in time. At least, let me think that through for a minute. Certainly for the afternoon, right? Because we don't have a lot of the deep level moisture. So that's the limiting factor for that one. And I don't want to misspeak because you can always get a freak occurrence, right? And if we still have a supercell that is active for mid-late evening, like I showed you, with the increase in shear that is going on, there's a lot of shear at play. Now, sometimes what I've seen is, and whether this is accurate or not to describe it this way, I've seen situations where there's almost too much shear. It's almost like that updraft gets ripped apart because there's just too much wind in the atmosphere and it can't stay stable. Now, whether or not that's the scientific term, I don't know. I'm not on the research side to go figure that out. I don't know if anybody ever did. It's just from operational meteorology of seeing that play out. But I've also seen other parts of the country where shear like that was just fine, like nighttime tornadoes, like along Alabama, Missouri, Mississippi, that kind of stuff, rather, and they had no problem. So in that little sweet window where you do have a lot of low-level moisture coming in with some instability and the shear is still present, and a tornado happens to get going and forming in that area, yeah, it can be a significant size tornado. It can be a stronger tornado. Again, it has to be a supercell type structure for that to occur, not a QLCS. However, on the QLCS events where I did see that we were able to get to a 2 or a 3 briefly, have been in a higher shear environment, even for that squall line to work with. So wind shear is a huge component of the rotation of a thunderstorm. So that's a good question to ask, and it's a valid one. Usually, typically, the higher shear you have, then the more spin, especially in the lower levels of the atmosphere, then the better opportunity you have for a stronger tornado. So that would be the case. I didn't look at the strength. We can do that here real quick. Let me pop this up for you. Where were we? And we can just do a forecast sounding for the environment. And we can pick different models. So we'll just say, for example, let me see it, because I have to find a sweet spot, right? So that's the issue. Okay. So, for example, what we'll look for is this bottom panel right here, which is effective layer significant tornado parameter, and it has what could potentially form in this environment. And this yellow line, all right, is where it overlays the boxes, whiskers of the probability of an EF1, EF2, EF3. And right now, at midnight here in Oklahoma City, for example, this particular model says we would be a sweet spot in the EF2 to EF3 category. All right. So that's in other words, that is a predictor of how strong the atmosphere would support a tornado should one occur. All right. So that's kind of an example of how that works. Now, every model is going to say something a little different. So let me go to, I'll do 29, and then we're going to flip through different model views. So for the HER, let's see what it does. So it's quite a bit weaker in the shear, therefore it's got a lower threshold number than the NAM did. All right, let's go with the other one. Oh, this one finally came in. I was wanting to see this earlier, so I'll go back to this now that it's in. All right, this one, again at midnight, that's what I picked. Back up to higher shear, so it's got like a strength of an EF2, bottom end of an EF3 category. All right, so let me go to this guy, because this is our experimental model that's supposed to replace what we currently use. So we call them CAM models. They're called convective allowing models, and we're supposed to be getting rid of them and phasing them out and replacing them with one supermodel. So you know how supermodels are. They be a little finicky, a little contentious. So we'll see what happens here. But for example, this one, it's got those showers in the morning like we talked about, moving off. All right, so here we go. Here's that afternoon blow up here between 3 and 4 o'clock. You see how they're broken up in nature? It's kind of more supercellular. If I do look at a forecast sounding, though, out here just to see what they're into. So we have a surface temperature of 69 and a dew point of 50. So there's a lot of dry air right here, which causes a very high cloud base. So in other words, you really can't get a tornado with this environment. You can get some pretty good hail, though. It says 2.75 inches in diameter. All right. Now let's go ahead and animate or move that through time. So there's 5 o'clock. See, there's a bunch of them still kind of broken up with long helicity tracks. All right, this means a lot of rotation, which probably means some really big hail in this case. Because again, I don't think that we'll have enough moisture yet to produce tornadoes before that time frame. Now, even here at that hour, we got some mid-level moisture, but we're still lacking the low level. But that's expected. All right, so let's go on into 6 p.m. All right, so this particular model is starting to lose their punch, starting to break up. Now, part of this is because, remember, we had that rain through central Oklahoma earlier. So you know what our temperatures are doing here? That's another downside. You'll learn that during the spring. When we have a big severe weather storm day, if you have cool rain, that kind of stabilizes the atmosphere, doesn't get a chance to rebound. As storms move into that environment, they weaken. So that's what these models are doing. They're showing them weakening as we get closer to central Oklahoma. So this particular case is starting to try to get a cap building in here about 6 o'clock. It's got a little bit better low level moisture though, 61 over 54. Decent hodograph showing up here. All right, but if we'll notice, running into that cooler air, all these storms start to diminish. There's one little engine, red engine that could here in the Oklahoma City area on this particular model data. Now look what has happened. By 7 o'clock, we've really moistened up the mid-levels of the atmosphere all the way down to the surface. We're now at 58 degrees over 55. So in other words, it's pretty saturated all the way downtown. And then we have a shear has gone through the roof around 421 meters squared per second squared. So in other words, we have a nice hodograph. It's not pretty, but it's decent enough. So the tornado risk will start to go up at this point in time. LCLs are still a little high on this particular panel, but they would come down on the next one, given if everything stayed the same. Now, of course, the storm will move off and it looks like it's going to get in the cooler air out here, Stillwater, so it dies down around 8. And then later it says, all right, we're going to redevelop storms down here. Now, why did the model pick this spot? Well, this is where those 60 dew points are coming in with very little cap, right? So we have very weak, remember I showed you a borderline weak cap here in central Oklahoma running in the cooler air. So these things start to kind of diminish just as the atmosphere starts to get good for them. Whereas down here in the south, now you've got a situation to where, again, low cap because they're running against some very good moisture sources down here of low 60s. So let's just take a look down here. So this is a temperature of 63 over 59. So there you go. It's pretty close. Much prettier hodograph for the shear profile. And so the tornado threat goes up a little bit. EF1 to EF2 categories where they're at in this particular model data. All right, so in other words, CAPE still isn't all that great. It's a few hundred joules per kilogram, so it's not like it's 1,000 plus. But the deal with CAPE versus shear is there's one versus the other, or you can have a mixture of both. So you can have a low CAPE environment with high shear, like that would be, or you can have a high shear environment with low CAPE, or you can have kind of a middle in the middle. Either one will get you a tornado, given other ingredients. But regardless, this model is still coming in. It's a little late in its arrival as far as what it produces. But it looks like it's generating thunderstorms here for the second batch to occur in the evening hours, probably in this area. Now, will it develop one or two somewhere in here? I don't know. We'll have to see what the new data comes in. Like I said, that one model did, but it was thinking randomly at 2 in the morning or something. So it's still possible we could get a couple of thunderstorms in here, especially if we have one of these little storms here that kind of die out and it leaves some little mini boundary behind. That's maybe all it takes. Remember, for a low cap environment, in other words, a low inversion layer that's easily broken through. If we have just a little boundary or something to work with, it might be all it takes with a stronger low-level wind to kick in to trigger something and get a couple things to pop up. So I'm still kind of questionable as to how the evening may go. I still think we may not be quite done with the event through about 2 in the morning. I still think there's an opportunity, a window there for some pretty rough thunderstorms that may produce a tornado. So that's kind of this particular thing is looking. All right, so that was a good question, which led into something completely different. So Max, what are the chances the dry line forms west of Beckham County? The dry line will probably form right on the Texas border. That's where that thing's going to be. It'll probably cross over just a little, but that's basically where the storm should fire. So one of the things, if you guys ever do want to look at model data on your own, you're trying to find where the dry line is going to be. Let me show you why this is important. We'll go to 24 hours. No, let's go to where do I want to go? 20. Yeah, let's go 21. All right, we'll use this for example. And we'll do this. All right, so just for example, we're going to show you different model estimations to where it thinks storms will be, just for 4 o'clock tomorrow, right? There's the global model, there's the HER model, the NAM model, high resolution NAM, and the RFFSA. All right, now why are they all over the place? Why are they different? Well, a lot of it depends on where the dry line sets up. So if you look at the European, it's got the dry line right out here. So we'll just do this little deal. Oops, I didn't want that. Get out of there. We'll do this guy. All right, so there's our dry line for the European. The GFS, okay, has a dry line like so. Not very, more linear, less of a bulge. The HRR, let's see, it's right along with the GFS. The NAM goes, oh no, we got that dry line way out here. The 3 kilometer NAM also says we got the dry line way out here. And the RFFS says, oh, we got the dry line back on the border like this to match the European. So when you're looking at model forecasts, each one's going to have a slightly different position as to where this dry line is going to be, and therefore the kicker of where storms are going to form. Now remember, when you're, wherever the dry line is, you will never get a storm directly on top of you unless there's absolutely no flow in the atmosphere, which is very rare. It's usually a late summer deal, a midsummer deal. But at the time of the year, you get a pretty good wind that kicks the circulation off the dry line, and then that thing forms and then gets the storm to go. So even though your dry line may be out here, so for example, in this part of Texas, your storms, by the time they get rooted and going, may not even be until they get to here, right? It may be like an echo on radar at 15,000 feet here, but by the time it gets rooted, develops and grows, now it's over here. So think about that when you're looking at a dry line forecast. So here's the dry line. The most eastward progression is here, just about Elk City, which means the most eastward progression any model would show thunderstorms developing would be east of Elk City, kind of in this area here. So it's not a huge difference between these. I mean, we're only talking maybe about what, 100, no more than 100 miles. Okay, so what happens here also is the moisture content. So for the RFFS, yeah, let's say that model name. They got some dew point values here at 4 o'clock, for example, in the low to mid 50s from I-40 southward. North, though, they have it in the 40s, okay? 3 kilometer NAM, it's got dew points in the low 40s up here, and it's finally got 50 down here in southwest Oklahoma. So less moisture to work with. The NAM, same thing. HRR, low up here northwest, better moisture down here in the southern southwestern quadrant. The GFS, which is not really used for mesoscale forecasting, just so you know, but for what it's worth, that's where that is. And the European, also not used for severe weather convective forecasting, and has a drier up here north, but a little bit moisture down south. So what we do is we shift toward those models that handle moisture better. Now the problem is each one of these have little biases and weaknesses. So for example, the HRR will sometimes mix moisture too far east and dry it out. All right, so if that's the case, and this little line right here should be back out here into the eastern Texas Panhandle, just about a few miles, which may be more in line with the 3-kilometer NAM. Sometimes 3-kilometer NAM has a little too much moisture. Sometimes the HRR has a little too less. So the RRFS is the man in the middle, the one in between. And it says, all right, I'll split the difference. I'll keep the dry line right here on the boundary of Texas and Oklahoma, but I'm going to crank the moisture up a little bit into the low 50s. So we shall see how the RFFS does with this outcome. So students at OU, etc., every year they run model experiments so that they can find out how well it performed, and then they do verification scores. And they use this data both in learning and predicting a good forecast package on how to utilize the model, find its weaknesses, explore its strengths, and make notes of it. But they also use it for the researchers and tweak it. Maybe it's not handling certain parameters good. So, for example, maybe it's mixing out the atmosphere too much in the boundary layer or whatever, and it has a tendency to, mix out and include too much dry air. Well, they have to go and see if they can tweak that. So, in the last couple of years, they've been doing that with these models. So, we'll see if there is a difference this season, and we'll just kind of keep it. Because remember, right now, it's considered an experimental model. It's not officially used for forecasting, even though it's used for forecasting. Does that make sense? In other words, there's not a single meteorologist that's not going to look at it and go, that's interesting. They're going to look at the other ones, but they're also going to look at the new one. It would be silly not to, because that's the newest tech. Let's see. Larry, let's see. Here in central Oklahoma, you have, other than the morning rain, through lunchtime, through noon, and when that gets out of here, it's dry, and then it would be in the evening hours after 7. So there you go. Dylan, I don't really think Tulsa's got anything to worry about. I think everything would be south overnight for Sunday. And then Amber, so I've got some kind of allergy attack yesterday and today. So I even took medicine, but I'm a little congested, a little baby headache. So I don't know, hopefully it's just that, not like a sinus infection coming on, because anybody got time for that. But anyway, so hopefully that was helpful on the explanation as to, some of the things you can look for here on our end. And I'm going to go ahead and look to see if that model did anything real quick later. Let's see. So we'll step this through. So that was 8 o'clock. 9 o'clock. So you can see these thunderstorms look pretty meaty down here in southern Oklahoma. Let's see what the forecast sounding looks like down there. Lifting condensation levels coming down. Heck of a lot of shear. All right, we'll go to the next one. So that was 9 o'clock. So now let's be 10 o'clock. So this has the appearance that we call a line echo wave pattern. It's not like a squall line. It's kind of like a hybrid cluster, but this tail end is acting as though it's a supercell. So the cap at the surface is trying to build in, but that storm is already going, so doesn't have to worry too much about it. But the models are estimating that it's still struggling with enough low-level moisture to get the cloud base down. But the shear is through the roof, so yeah, that one would be potentially tornadic at that time. And that thing moves up toward McAllister. There's a little bit of helicity track with it. That little guy right there, indicating rotation within that. But also has kind of a linear appendage. So it's a hybrid. It's a hybrid cluster in that, you know, if it actually were to come out exactly this model anticipates, then it would struggle to produce a tornado just based off of the structure of it. And then after that, it looks like it's got additional thunderstorms that kind of keep firing in this area in southern Oklahoma, North Texas after that for probably the next few hours. But yeah, it's got very low cape in this environment, even though it's got some pretty decent shear. It's not quite getting the low-level moisture, though. It says a dew point of 56. So it's running into a little bit more stable atmosphere from earlier in the day and dew points that aren't closer to 60. So it dropped by 4. That kind of weakens it as well and keeps it more of just a hybrid cluster of pockets of hail and wind. So that's kind of what that interpretation looks like in that particular data source. If I go back down here on these guys at that point in time, let's see here. So much better shear back in that part of the state, and dew point back still is 59. So there you go. So again, parameters are better for anything to try to be tornadic, say for example in this part of the region than it would be in this part of the region. So it's kind of like they go good gangbusters here, then they move out of this sweet favorable environment, and then they kind of go into an area that's not so favorable. Let me see here. Yeah, so if you look at the cape and shear values, the axis is still running west of 35. Kind of see a faint view of it here as far as instability goes. You know, the colors, outline this for you. Kind of a light gray, comes up like this, right? So this is your instability axis of moisture. And so that cluster of storms that forms in this area has favorable shear to work with, and it's already on the fringe of the decent moisture. And then once it crosses over and gets into this area, it has some really decent shear, but it's got no instability, no moisture instability for surface anyways. At that point in time, it'll have to just use elevated instability. So that's why the transition over. Surface instability is better for tornado genesis, but needless to say, that's the little area we're looking at for tomorrow evening, overnight, into the after midnight period. All right, well, that's it. I mean, that's pretty much all there is to talk about. Nicole, so yeah, there might be a couple of power outages if, you know, on the local level, if you get a pretty nasty storm with some wind, etc. Plus, honestly, we'll probably get power outages anyway during the day because we are going to have winds in excess of 50 to 60 miles per hour wind gusts, especially out in west central, northwest Oklahoma. So that can cause some power outages there. So I wouldn't be surprised if that happens. It's not like a widespread thing, but it'll be enough. There'll be a few of them. But otherwise, it'll be a good event for wind. And then not everybody's guaranteed to get thunderstorms, of course, or rain for that matter. But the ones that do, you'll get some pretty decent rain in some cases. And, of course, with some thunderstorms, well, you get some pretty good hail. Hail and wind, too. We'll watch that threat for a tornado. All right, listen, I gotta get out of here. I stayed on way longer than I was going to. But you guys asked some good questions, so I wanted to make sure you had your questions answered, because that's what I do, right? Gonna help you out. That way you understand it, and you're prepared for the event. You're not scared of the event, and you know the real deal. All right, you guys have a great rest of your evening. Again, thanks for your support. Make sure you get my weather app. It's called AT's Weather to Go. It's free. Apple, Google Play. Just search my name, Aaron Tuttle, or AT's Weather, and it should populate for you, and you can download it. Doesn't cost you a penny. It'll predict tornadoes before they happen. Give you about 15 plus 20 minutes of preparation before they occur. You imagine the old days if they had 20 minutes to prepare before a tornado happened? That's insane. That's where technology is today. It's great. I would use it if I were you. All right, we'll talk again soon. Take care. Good night.